This will be for the con assignment, normal distribution, area between 2 points. So just a brief overview. The way you find the shaded area between 2 points on the normal distribution curve, basically you need to use the z-score table, okay? And when you look up, say, this z-score right here, it will give you the area under the curve to the left of that z-score, okay? And then when you look up the other z-score right here, again, that will give you the area under the curve to the left of that z-score. So what you want to do is take the value for the z-score for the first one and subtract the value for the second one. You have to look on the table. So basically, we're subtracting this area from this entire area right here. And that's how you get the area in between. Okay, so for these, you're going to have to calculate a z-score twice. It says a set of college students are normally distributed. The mean is 170.4. The standard deviation is 10. What portion of students are between 170.5 and 180.3? Okay, so remember the mean is represented by the Greek letter mu. The standard deviation is represented by sigma, and the values given, those are the x values. Okay, if you want, you can call them x1 and x2. It doesn't really matter, but we're calculating z-scores. Okay, recall our z-score formula, x minus mu divided by sigma. So we're going to do that twice. Okay. The first x is 170.5. And the other x is 180.3. Okay, and we had mu and standard deviation in the problem. Let's see. Mean is 170.4, that's mu, and standard deviation is 10, that's sigma. Okay, so subtract 170.4 and divide by sigma, which was 10. Same on the other one. Subtract 170.4 and divide by sigma, which was 10. All right. So you can do it by hand or on the calculator. All right, I'll do the calculator just so I don't make a mistake. Okay, so for this z-score, I got 0.01, and for this z-score, I got 0.99. So we need to look up both of those on the z-score table and then just subtract the values. All right, so the first one was 0.99. We want to look that up. All right, these are both positive, so we're on the positive z-score page. All right, let's look up 0.99 first. Here is 0.9, okay? And for the second decimal place, we're up here. This is 0.97, 0.98, 0.99. All right, so we just go by where they meet. All right, so from the 0.9, you just go across. Okay, and then from the 0.09, you just go down. And that number is 0.8389. Okay, basically, that gives us the area under the curve to the left of the z-score. All right, so we have 0.8389. All right, and then we want to subtract the value for 0.01. Okay, so we're going to use our table once again. All right, let's see, 0.01. So here is 0.0, right? This is 0.00. This is 0.01. Okay, so we just go here and we go down. You see where they meet? That's 0.5040. Okay, so for this value right here, 0.5040. Okay, so basically this just tells you the area to the left of the z-score, and we're going to subtract these two. Okay, and I got 0.3349. All right, now if you ever accidentally reverse these two numbers, then just take the absolute value. In other words, change the sign and make it positive, because you can't have a negative area. All right, but I just like to always put the larger number first. 0.3349. So enter that in the box. 0.3349. Okay, so it says 4 decimal places. Luckily, that's what our table has, 4 decimal places. All right, and what this number represents is actually a percentage in decimal form. If you move the decimal over 2 places, that's 33.49%. So that means the portion of students between 170.5 and 180.3 is going to be 33.49%. Okay, set of average city temperatures in December are normally distributed. Mean is 16.3, standard deviation is 2. What portion of temperatures are between 12.9 and 14.9? Okay, so here's our formula for the z-score. All right, we're going to do 2 of them as always for this exercise. It says the mean is 16.3. That represents mu. Okay, and the standard deviation is 2. That's represented by sigma. And the 2 values given, those are the x values. All right. So using our formula, x is first. 12.9 is the first x value. 14.9 is the other one. Okay, and then subtract mu. So minus 16.3. And then divided by sigma. So we're dividing by 2. Okay, both of these I'm going to do in the calculator. Remember, when you subtract, hit equals and then divide by 2. Okay, so our 2 z-scores are negative 1.7 and negative 0.7. Let's go to the table. So we have our 2 z-scores, negative 1.7, negative 0.7. So we want the page with the negative z-scores. Okay, so let's go to negative 1.7 first. Here's our z column right here. All right, this is negative 1.7. Let's see. Negative 1.7 right here. Okay. This is negative 1.70 right here. Okay, we don't need to add any decimal places, so we're just on the 0. And you go down, and it meets right here. 0.0446. All right, and then we want negative 0.7. Let's see. Here's our z-scores. Negative 0.7 is right here. Okay, we're not adding any decimals on it, so we want negative 0.70. All right, so we're just going down this column right here. All right, so that's 0.2 0.2420. Okay, that's the area to the left. 0.2420. Okay, like I said, you can put the bigger number first when you subtract, or you can just subtract like this and make it positive. Take the absolute value. I'm going to do it on the calculator. Okay, I got negative 0.1974. That's just because I didn't put the larger number first. You can't have a negative area, so you just make it positive. Okay, so it's 0.1974. All right, and you just enter that number in the box, 0.1974. So that's actually 19.74%. But we keep it in terms of a decimal. All right, one more. Set of computer science exam scores are normally distributed. Mean is 71.33. Standard deviation is 3. What portion of scores are between 68 and 77.99? Okay, so this is your mean. That's mu. This here is your standard deviation. That's sigma. And the values given are the x values. The z-score formula, x minus mu divided by sigma. All right, so we're going to apply that twice, one for each score. All right, so the first x is 68. And the second x is 77.99. Okay, the mean or mu is 71.33. And we are dividing by the standard deviation, sigma, that's 3. Now, both of these I'm going to do on the calculator. So my z-scores are negative 1.11 and 2.22. So I'm going to use the page for the positive scores for this one and the negative scores for this one. Everything else is the same. All right, so the first z-score was 2.22. I'm on the page with the positive z-scores, and the z column is right here. We're looking at 2.22. All right, let's go down the column here. And here is 2.2. All right, so we're going to go across to the right, and we want 2.22. This is 2.20. 2.21, 2.22. All right, this is the second decimal right here. So we're going to trace this column down. All right, we're going to keep going down. And over here, we keep going to the right. And they meet at 0.9868. 0.9868. So that's going to be the area to the left, 0.9868. Okay, and now for the other z-score, we're going to have to go to the negative z-score table. Okay, so we're looking up negative 1.11. All right, here's the column with the z's. Keep going down until you find negative 1.1. That's right here. And we're going to go to the right. Okay, so this is negative 1.1. This is negative 1.0, negative 1.11. All right, this is the second decimal, so we're tracing this column down. All right, so go down like this. Keep going. And this one you go to the right, and here they meet at 0.1335. Okay, so this one here is 0.1335. Okay, so we're going to subtract 0.1335 from 0.9868. Okay, that was the z-score for negative 1.11. All right, so we're just subtracting these two. Do it on the calculator. Okay, I get 0.8533. So that's it. You just enter that number in the box. All right, right here, 0.8533. All right, if you want to put the 0 in front, you can and make it 0.8533, but that's the same thing. So to sum it up, use the two values that they give you, okay? Calculate the z-scores for each one, and then go to your z-score table, look up the values, and subtract those two areas.